Hello and welcome to lesson 2 of week 16, where we're going to graph linear inequalities. To get started, I'm going to look at something we did way back in, I don't even remember what month it was, but it was a long time ago. And it was an inequality. We solved this by moving 5 to the other side and then dividing by 3. You're getting x is greater than -1, and we graphed it on a number line. We had an open circle at -1, and we shaded the numbers bigger than -1, so we shaded to the right. That kind of stuff is going to come into play here with linear inequalities, but there are some differences. First difference that you should see is an inequality which involves a linear function with an x value and a y value. So it's got two variables. The one that we just did had only one. What does that do? Well, it creates a region on the coordinate plane that has a boundary. Instead of an open circle or a closed circle, we're going to have a solid line or a dotted line. And you're going to be able to tell that by looking at the symbol. Greater than or equal to, less than or equal to are going to be solid lines. Greater than, less than are going to be dotted lines. Now, this probably is a little confusing right now. Let's do a couple examples to make sure you understand. Solution to a linear inequality is any and all points in the shaded area of the coordinate plane that make the equation true. So we're going to graph this like it's a normal line. We've done this before. The y-intercept is 6. The slope is -3. So down 3, right 1, down 3, right 1. Do that over and over again. Because the inequality is a greater than, not equal to, it's a dotted line. So you see that's a dotted line there. Now, the last thing we need to remember to do is shade. So we're either going to shade above that line or below that line. And how do we determine that? Well, the symbol means above. Greater than means above, less than means below. Okay, we shade where the y's are greater. All right. And a good thing to do, good habit to get into, is to check your work at the end. It's a good one to look at is 0, 0. 0, 0. Is it a solution? Well, if I look at my shading right now, it is not in the shaded region, so it should not work. Let's see if it does. Put 0 in for y and 0 in for x. I get 0 is greater than 6. Is that true? No, it's not true. If it's not true, that means we don't shade that way, which is good. So don't shade the side of the line that has 0, 0. We didn't. Therefore, we have shaded correctly. Okay. Let's go back a slide real quick. One more thing I want to talk about. A point on this line here, since it's a dotted line. So let's say the point 2, 0. Is that a solution? If you plug it in, you're going to find that if you put 2 in for x and 0 in for y, you're going to get 0 is greater than 0. Is that true? No, 0 is not bigger than 0. It's equal to. So a point on this line, on a dotted line, is actually not a solution. A point on a solid line is. So it's one thing I didn't put in the slides, but I want to make sure you hear. Okay. We've also got a word problem to look at here. A company makes nylon and canvas backpacks. The profit on a nylon backpack is $3, and the profit on a canvas backpack is $10. What are 3 possible combinations of backpacks a company could sell to make a profit of more than $250? So we're going to write a linear inequality to describe the situation. We're not trying to get exactly 250. We're looking for anything more than 250. So that's where the inequality comes into play. Well, we're going to say N is the number of nylon backpacks and C is the number of canvas backpacks. 3 times N is the profit for each nylon backpack, and 10C is the profit for each canvas backpack. We want that to be greater than 250. There's my inequality. Now let's graph it. We have to graph it, we want to put it in slope-intercept form, so we have to subtract 3n, and then divide by 10, divide everything by 10, so we get -3/10 n plus 25, and if we graph that, 25, down 3, right 10, this one is a dotted line again, and then we want to shade. We shade above this line, so you see that we shade up here. Any combination of nylon and canvas backpacks that's in this shaded region would give me more than $250. So one possible solution is 0, 30. So if I sell no nylon, but I sell 30 canvas backpacks, I would make enough money. 25 and 35 definitely would make me enough money. 50 and 50 definitely would make me enough money. Okay, so that is an example of a word problem with linear inequalities. So quick summary, because we're going to be using this in the next lesson. First thing you want to do is determine if the boundary line is solid or dotted. Second thing is to graph it, which is review. Third thing would be to shade above or below that line. And the last thing would be to check your work. So we're going to use that with 2 inequalities in the next lesson. But for now, it's the end of lesson 2.